is Mark Jacobs. I am the engineering manager for a Google product called DoubleClick Campaign Manager. DoubleClick Campaign Manager is a product out of Google that's focused on giving the world's largest advertising brands and their agencies the ability to create their display online campaigns. Using our tool, these people can upload their creative artwork for their advertising campaigns, and they can set all the metadata that configures where their advertising is shown, to whom, when, and under what circumstances. So I'm not here to talk about advertising. I'm here to talk about large applications. So DoubleClick Campaign Manager we're out of the New York office. How many people here know that Google has a New York office? Good. In fact, the New York office is the largest development center outside of Mountain View. It's huge. We occupy an entire city block. And it's really the home for a lot of great products, Google Docs, and lots of advertising products. Why are we here talking today to you? Well, me and my team are here because DCM is one of the oldest and largest Angular applications we believe in the world. So we began back in November 2010, so we've been using it over 3.5 years pretty much. Since v0.9, we've gone through lots of teething and growing pains along the way. We currently have over 20 JavaScript engineers working on a single product. We've got over 71,000 lines of just actual business code, another 133,000 lines of test code, 26,000 lines of markup, 130 controllers approximately, directives, services. It's big. And the reason why we're here talking to you today is because once an application gets to a certain size, you begin to expose fault lines that you probably don't see in smaller applications. Fault lines that affect velocity, reusability, software quality. And so me and my team are here today to talk to you about some of our experiences as we scale up large Angular applications and talk about some of the solutions we come up with along the way. After the talk, me and my team will be out by the Google desk. We have some additional swag to hand out to people who ask really great questions. We'll be happy to talk to you. So with that, let me hand it off to Ido.
All right. Thank you, Mark. Hello, everyone. So the first topic we're going to talk about is authorization and conditional features. So let's start with authorization. So when you have a smaller application, maybe you don't really need authorization, but as your application grows larger, you need to start dividing your application into sections and decide which users can see what parts of the application. We do that by basically returning an active user profile for every authenticated user. So the active user profile is going to contain a name, permissions, language, email address, a bunch of things about the user that help us figure out like what the user can or cannot do in our application. And once we have this information, we basically need to store it somewhere in the application where all the other parts of the application can access it. In case the user is not authenticated, then obviously we have to redirect them to the login page, and then once they are authenticated, they're going to go back and we're going to have their profile information. So originally when we started the application, we did that by we basically did everything on a client. We didn't really have anything on the server side. We just served static files. So our index.html was our main page. And the way the load sequence worked is like we loaded the index.html page. And then once the browser got that page, it started doing everything that you would expect. So it would load all the scripts, the style sheets, the images, parse all the JavaScript, which seems maybe like not a big deal, but we have like 1.7 megabyte of JavaScript code. It takes a few hundred milliseconds. And then bootstrap the Angular application, and then finally request the active user profile. And then at that point, if everything was okay and the user is authenticated, we just stored it in the app scope and we loaded a default route. If that wasn't the case and the user wasn't authenticated, we redirected them to the login page, and at that point they had to restart all over again. So they had to put their login, and then they would issue a second request to index.html, load everything, request the active user profile. So while it worked when the application was small, it wasn't really efficient. So the few problems we came up with when we dealt with it was that we basically spent time loading a bunch of resources and bootstrapping the app before we even know the user is authenticated. And then, once we got the active user profile information and we put it on the app scope, we kind of like messed up because like now we basically have a dependency between our app scope and all the child scopes that are in your ng views. This makes it very difficult to test. So like basically when you write a test now, you have to create the app scope even though you're testing the controller within it. And the app scope really is more of a shell for the Chrome of the application. We don't really need to create dependencies between the shell of the application and the actual business logic. The third problem was that we couldn't really pass the active profile around efficiently, and we couldn't pass it to services during the configuration phase. And that's because by the time we issued the request for the active user profile, the modules are already like loaded. They're already configured. So we can't really pass in, let's say, the language information to the, let's say we have a help directive that shows help information, and we want to say that like the language of the user is Japanese, so we want to show it in Japanese. So the solution we came up with is basically using server-side rendering only for the index.html page. And obviously, like you could do server-side rendering in many, many ways. You could do it like with Node and Jade if you use it, if you want to use that for templating, or you can use App Engine, or we use Clojure templates. So the way we did that is like when a user requests index.html, we inject the active user profile into the page as a simple JavaScript object. And once we load Angular, the information is already there. So at that point, we can basically take that information and wrap it in an injectable constant, and then send it through, to the entire part of the other parts of the application. So the benefits are, well, for one, we have one less round trip because we don't have to do the get active user profile request. The second part is that like we're only loading index.html if user is authenticated, because the checking whether the user is authenticated is done on the server side instead of being done on the client side. And finally, the active user profile is now available to all the other parts of the app using injection, which makes it very easy to mock during tests and very simple to understand. So this is how it looks on our main page. And like I said, it's very simple. You can just look at the 2 lines in the middle. Those were generated by the server side. So if I look, once the application is loading, this is already available. And then the next step would be to make it into an injectable constant. So we have an Angular module that contains all the logic for it, which is pretty simple. We just make a copy of the global variable to make sure that like the user can't futz around with it later. We can add functionality on top of it. So for example, I can later on say active user can edit account, and that would be a function that would tell me if the user can edit the account. And then finally, we provide it as a constant. And that's important because this way you can inject it into your service providers. So now the scenario that I described earlier with the help directive that displays help in different languages, I can inject the active user profile. It can check the active user profile language and configure it properly. So once we did that, we already had the index.html rendering on the server side. We started running to scenarios where we wanted to separate certain features and show them conditionally to different users. This is important because during development we try a lot of things. We don't necessarily want to show features that are in beta to all the users. And in scenarios outside of our product, it could be that you have features that are paid for, and you want to block those features for users that didn't pay for them, or you want to show them to users that did pay for them. So when you implement conditional feature loading, there are basically 2 main aspects for that. You want to load only the code for features that the user can access, because obviously, why would I load a bunch of controllers and directives that are not used by the current user? And the second part is to actually change existing pages. Let's say I have a certain page that should show account information, but it has a specific area that is only visible if you have a certain feature turned on. So I want to hide and show that section according to the user's feature set. So since we have index.html and it is rendered on the server side, now it's pretty easy to kind of load features conditionally, because all I have to do is check the active user profile on the server side. If it has a certain feature, I just embed a script or in a link tag for the scripts, for the JavaScript and the CSS, and that takes care of the loading stuff conditionally for that feature. But limiting access on the controller and the views takes a little more handling. So on the controller side, you basically inject your active profile service, and on the active profile service would be all the feature set that the user can access, and then you can check on your controller whether a certain feature is enabled or not. On the views, we could use ng-show and ng-hide, but that's a little problematic because ng-show and ng-hide don't really remove the HTML from the page. And every time that your application runs, every digest cycle, it's going to have to evaluate all the expression in that like hidden block to make sure that it shouldn't be shown. So it sounds kind of small, but like we have large sections of HTML that contains dozens of directives in them that are conditionally loaded. So this could be really a hit on performance if you don't get it out of the page. So what we did is we came up with a way to remove those snippets of JavaScript, of HTML from the view that we didn't really need for a specific feature. And we did that by annotating our HTML with custom attributes. So basically, we call them keep and omit. So if you look at the first div, it's just a simple div, and that everyone can see that. Every user could see that when the view is loaded. The second one has a data keep attribute on it, and the value for it is feature 1 and feature 3. And that means that like this div is going to remain on the view only if the user has those features turned on. And if he doesn't, this view is going to be removed. It's not going to be hidden or ng-switched or anything like that. It's just not going to be there. And data omit is basically the opposite. So if the user has feature 2 turned on, we're going to remove that section of the page. And the way we implemented it is basically using Angular's response interceptors. So the HTTP service provider basically lets you intervene in the pipeline. When you issue an HTTP request, when the response returns, you can basically insert your own function that does something before the result is handed to Angular. So what we did is basically we created an interceptor that would take the view that we request from the server and then look for those custom attributes we just saw and strip them according to the user's permissions. And we're just going to do a simple code walkthrough. Second. Okay, there we go. Let me make it a little larger. A second. So, there we go. Is this? Yeah. Seems clear. So the first part is obviously defining an Angular module and injecting the HTTP provider into it. And then we're providing an interceptor by simply pushing it into the interceptor array. And then we also inject a few services that we want to have in our specific interceptor. We have a few regular expressions here to figure out where, if the attribute is actually on the view and whether it's an HTML view or it's like it could be a JSON response. Obviously, we don't want to modify things that are not requests for HTML views. And then what we do is we test if it's an HTML page. We test if it actually has a data keep and a data omit attribute in it. If it does, we convert it into an HTML fragment. And then we basically use jQuery to iterate through all those HTML fragments. We read the values of whether it's a keep or an omit value. And we determine whether the user, using the active profile service which we injected into it, has the feature turned on or off. And according to that, we end up removing that feature or not removing it if the user has permissions. We change the response data. So when Angular gets the HTML view, it's not going to have the things we stripped out of it. And we actually put it in the template cache. So the next time the view is requested, we're not going to do that work all over again. Just doing it once, we're catching it, and that's pretty much it. So this way you have a view that is clean. It doesn't contain any data that is not the data that the user is supposed to see. And you get the performance benefit, and you get to hide things, because sometimes those experimental features are things that you don't want to show users until you release them. So that's my part of the presentation. I'm going to bring up Rachel to talk about code organization patterns. Thank you.
Hello. Hi, I'm Rachel. I'm going to be talking about different code organization patterns. So why is code organization important for scalability? As your application grows, so does the size of your controllers. Our application is very large, as you saw. Many of our controllers have thousands of lines of code. And having your controllers be this large puts pressure on improving code organization and reuse. So the goals of organizing your code is to avoid controllers that are very long because they're very complicated, to prevent copying and pasting code between controllers, and to have code that is single responsibility and easy to locate. So here is just one example of a complex controller in our app. It has over 3,500 lines of code, but that's after we've moved a bunch out. It probably would have had 7,000 lines if we didn't. So you can see why this can become necessary. So as we've grown, we've tried different ways to organize our code. And we've come across the 5 different methods. So with regular JavaScript, you can do inheritance, composition with mixins and JavaScript objects. And then using Angular, you can do composition with services and helper controllers. So inheritance, you all know what inheritance is, I hope. It's good to use, we found, when you have basic features that are logically make sense in a shared parent. For example, we have lots of lists of objects. So we have a shared base list controller, which contains common things like sorting and paging, et cetera. And the other controllers inherit from them. The problem with inheritance, though, is that it's easy for the hierarchy to become too deep and too confusing. Some of our classes got to the point of having 4 or 5 parents in them. But more importantly, a lot of code needs to be shared across controllers that are not in the same branch of the hierarchy, so you can't even use inheritance. So I have a couple examples for a theoretical pet daycare. So in this case, we have cats and dogs and other pets. So we have a pet list controller, which has sorting on it. And then the dog list controller inherits from that. You can do inheritance in Angular with injector.invoke to call the constructor of the parent. And I have JS fiddles for all of my examples, which I won't go through the code of. You can look at it later, but just to see how it works. It's basic list. I have cats and dogs. I can sort. It's fine. OK. The next thing we tried once our inheritance became too unwieldy was mixins. A mixin is an object whose methods are added onto another object or mixed into it. You can do this with angular.extend, and there's other ways to do it as well. This works well when you want to add method from shared code directly onto the scope or controller, or when you have something very specific to override. For example, we do it with patching certain functions temporarily. But we found that you should use it sparingly. It's very easy for it to get out of hand. The problem with mixins is that with very large files, it's not clear where the code is coming from. Mixins are very tightly coupled to the controllers they're mixed into because it assumes that the controller contains certain methods or fields. And when you overwrite a method with the mixin, you actually completely overwrite it. You can't access the original. So here's an example with mixins. Let's say I want to use sorting somewhere else, so I move it out into a mixin. If I mix it into the scope, then I now have these sorting functions on the scope, and I don't have to change my UI because I can still access it by calling sort, reset sort, etc. So my example for this, pretty similar to here. Sorting still works. You can see I have this sort mixin. The next way for code reuse is composition with JavaScript objects. This is just moving functionality into JavaScript objects and using them on your controller. This works well with simple objects. Anything that's too complex and might need a service or something that's Angular controlled, like a filter, et cetera, won't work with this. But this also is good when performance is critical. For example, in some of our pages, when we have hundreds of items, we found this to be faster than using Angular for instantiation. But of course, the problem with this is that you can't use any Angular dependency injection. So here's another example with sorting. I have a sorter object, and I just create a new instance of the sorter object in my list controller. Oops. The problem with this, well, not problem, but the difference between this and the mixin is that now the UI has to reference sorter.sort, sorter.resetSort, et cetera. But you can see, though, if you had a controller with 6 or 7 mixins, this is a little more understandable to see where your code is coming from when you try to find it in the UI. And here's my example. I added some more features. You can unsort, et cetera. OK, so the 2 ways that we prefer the most is using Angular to help us. So the Angular recommended way to move code out of controllers is with services. I think you all probably know what services are at this point. It's a singleton function or object that can be injected into a controller. We found it works well with common functionality that does not require saving local controller state because it's a singleton, for example, with logging or parsing data. And it also works well with anything that needs to be shared across different controllers and must be a singleton. For example, we have our modal dialog as a service so that any controller can reference it because there needs to be one on a page at a time. This has the benefit of being fully dependency injected, and it also helps with testing because you can create mocks of your services to use in other tests. So with my pet daycare now, I want to start adding a feature where I can walk dogs. And maybe I want to use this not just in my list page, but if I have a controller that does a single dog or something. So I have a dog walk service. In this case, it just says I'm walking the dog. But you can see here in the controller, you inject the service, and then you can just call it when you need. And so here's my example. As I walk the dog, it just lists out the dogs I've walked. Okay. And the last way that we've been using quite a bit is composition with helper controllers. So a helper controller is a name we came up with. It's like a regular object, except that we instantiate it with the $controller service in order to get Angular's dependency injection. We've come up with different names: companion controller, scope buddy, I don't know. We have a hard time knowing what to call this, but it's basically just an object with dependency injection. This works well when your objects need to reference other Angular objects, which a lot of our more complex ones will need to. But unlike services, this supports multiple instances on a page, and it also allows you to save local controller state. The benefits are that it's fully dependency injected, and it helps you support composition when services won't work. So now instead of just walking dogs, I want to keep track of which dogs were already walked. So I move this into an object called the pet walker manager. But because I need to use the dog walk service I created before, I'd make this as a helper controller. So you can see my object here expects the dog walk service to be injected. So to instantiate this, all I need to do is call $controller instead of new, and it will do Angular dependency injection for you. So back to my example. So you can see now that it says not yet walked on the dogs we haven't walked, so it just simply keeps track of which ones we've walked already. And just another note about helper controllers. You often need to share state between a helper controller and the page controller that you're using it on. There's two different ways to do this. For example, if my pet walking manager object needed a full list of the pets in order to see who needs to be walked, one way is to have the helper controller use a child scope with scope.new so that it can access all the fields on the parent. This is still very tightly coupled to the page controller, so it's not ideal, but it works in cases where you have a lot of things you have to reference. Another way is just to pass it into the configuration, a function that returns a list of pets in this example. So in conclusion, as your application grows, try to avoid your controllers getting out of hand. You don't want it to be too complicated, you don't want there to be duplicate code, and you want it to be easy to understand. So our general rules of thumb, in summary, is to prefer composition over inheritance. For composition, we try to use Angular services and helper controllers whenever we can. Regular JavaScript objects for simple things, and we try to keep our inheritance fairly shallow. We try to minimize the use of mixins because they're just a little bit harder to find and locate. And we try to keep our code single responsibility. So, when we use a framework, it's easy to kind of let the framework do everything for you, but don't forget also about object-oriented design principles and keeping your code clean. Yeah.
Can everyone hear me? Cool. So, hi, I'm Jeremy, and I'm going to be talking about going beyond Angular's built-in services. So Angular provides a lot of services to cover your application basics. There's $resource for reading and writing server data, there's $cookies, $location, $timeout, and so on. So with these, the framework gives you a lot of tools to create really great web applications. But as your application continues to grow larger and larger, the basics might not be enough anymore. And to illustrate this, I am going to talk about two services that we created that are wrapping $resource and HTTP backend to make our application more scalable. So what does this have to do with scalability, though? So our application has over 30 top-level REST endpoints. Each page, on average, has requests for 7 different types of entities with different business logic and validation rules. And while $resource provides a really great API for reading and writing this data, we can do more. So we tried looking at this to think, how can we reduce the amount of boilerplate we're writing to make our code better organized and improve our velocity because of that? And to this end, we created an API service that wraps $resource. So what does our API service actually do? So first, it gives us a simple, declarative, and fluent API for configuring and defining our endpoints. So this configuration API is exposed via an Angular provider. The provider is consumed during the config block, as you can see, of an Angular module before the rest of the application is initialized. Using a provider like this allows us to separate the code for the API service from the actual configuration that is specific to our REST API. This lets us use the same service in other projects that have different REST APIs. So looking at this configuration, you can see it really is simple to read, where from our API provider, we're defining an endpoint for songs. We're specifying the route for that endpoint. We're declaring a custom action to that endpoint. So this is a post. The action is called remix with preset parameters for the request. In this case, fresh is max. And we're also specifying a model, which is a constructor for the data coming back from this endpoint. I'm going to talk about that model in a minute. So defining this places this song endpoint onto our API service, as you can see at the bottom of this. And once configured, consuming the API is really straightforward. All of the standard HTTP methods, get, put, post, delete, are automatically added to the endpoint in addition to the custom actions that we defined above. And it works just as $resource would work when you're creating endpoints like that. You're just saying API.songs.get, give it your parameters. You're going to get a promise back. And as you can see, this is what it looks like to use. A custom action remix promise equals API.songs.remix. Now, more about that model, though. So we wanted to add this configuration option because we wanted to automatically wrap the response data into more logical entities. So say your application is fetching songs. It's a lot more convenient to work with it, work with what you're getting back when you're getting some instance of a song object instead of raw data. And this instance is decorated with functions that have the business logic for those entities inside them already. So we accomplish this feature by taking advantage of the promises in Angular. The API service simply takes the promise returned from the underlying $resource call and adds a resolve function that instantiates the model object and returns another promise that is resolved with that model instance instead of the raw data. For those of you who are unfamiliar with promises, I believe there's going to be another talk later today that goes more in depth about them. So another neat thing is that the API service uses Angular's $injector service and its instantiate method to create these model instances so that they can receive dependency injection. This makes the models more flexible and easier to test, and you can use the other code that you've written in your services. The benefit of having these models is that it makes your code cleaner. having the logic for each type of entity reside within that entity makes it easier to reuse across your whole application so that it's not really tied to any one controller, and it also lets you write code that is more semantically readable. As you can see in this example, if we're binding to our current song, we can call directly on that to toggle star, which is obvious what it does. This is a very simple example, of course, but it conveys the idea behind the pattern. Now, another neat thing that we can do, because we have these model objects, is use them to define some data transformations that automatically happen as the data is moved between the server and the client. Now, this is something that could be really useful if you're working against a server API that is outside of your control. Maybe it's a third party, or maybe it's legacy and is not worked on anymore, and that backend is returning data in a format that's not really the way you want to work with it on your UI. This is the case we have on our project, where our application is a front end that's consuming data coming from a backend that's maintained by another team, and it's difficult to make changes to that. So it really helps us to be able to say, well, I just want to work with the data in this format, and I'll configure my model object such that as long as I'm on the front end, I'm just working with it in the format I want, and it's automatically transformed as it comes from the server and goes back to the server. The implementation of this is really straightforward. We just have two functions that are defined on the model object, an after load and before save. Each of these are invoked automatically by the API service after a GET request or a put post request, respectively. And you would put in here any code that is going to manipulate that model's instance data, its members, to put it on the way in the format you want to work with, and on the way out back to the format that the server is expecting. And it's really convenient to be able to have this happen automatically. So what I've talked about so far in what this can do is really just simple examples. You can do a lot more depending on what your application needs. So maybe you want to add some application level caching. Maybe you want to prevent post requests that occur when your model is failing validation. The key is to identify what infrastructure enhancements that you can make to reduce boilerplate and keep your code more organized and easier to work with. And the same idea doesn't apply to just your production code. It should also be applied to your tests as well. So most of you, I'm sure, are familiar with HTTP backend for testing your HTTP request. It looks something like this. You're saying with your HTTP method, you're expecting a request to occur that matches this URL. But these URLs over time, they get longer, especially if you have a lot of query string parameters. They're hard to read, they're hard to change, they're hard to debug. So we weren't really happy with using these all over the place. So we created a wrapper around HTTP backend that I'm going to call fake API here. And it looks something like this. It's very similar to actually using the API service to make requests, but instead of making requests, you are, from your endpoint, expecting that a request is going to occur. We have methods like expect get list, expect get by ID, expect update, and so on. From this, you can, like HTTP backend, either respond with a particular set of data that you're specifying on the spot, or in the case of our fake API, just say returns default. And this default data is specified in the configuration for that fake API endpoint. So after this, we have the code that we're testing, in this case load cogs. We flush the HTTP request like we normally would with HTTP backend. And this is where it's really interesting is we built these fake endpoints to be able to be consumed by some custom Jasmine matchers that allow us to make some really granular assertions about the way that the request was made. In this case, we're expecting that cogs were requested with parameters finish, shiny, metal, and brass. And this is far more concise and readable than using the whole flat URL string. It's a lot easier to maintain and debug. And so the configuration for this happens in much the same way as our API service does. It's declarative and fluent, and it includes the configuration for adding response or default responses. This is really nice because it helps prevent copying and pasting test data between tests. Test data can get stale and inconsistent, and by having a single source of truth that's all specified in one place in that default data, we help reduce the amount of time people spend hunting down why is this wrong. And once again, the custom Jasmine matchers really allow us to do more granular and readable assertions. And so you may be wondering, well, how does this apply to my project? The takeaway is to realize that Angular gives you the basics with which you can build your own tools. You have to identify the code paths within your application where you can expand the infrastructure to cut out boilerplate, improve readability, and hide complexity. Maybe your application only has a few endpoints and it's not really worth the investment to add in a lot of infrastructure around HTTP requests, but maybe you do a lot of manipulation of cookies, so it makes sense to write your own cookie wrapper that adds functionality that is specific to your product. And it's also important to remember that this mindset should be applied to your test as well. As you saw earlier, our application actually has more lines of test code than production code, and so being able to maintain that easily is very important. Both of the examples that I talked about today, the API service and the fake API service, have code right now available on GitHub that you can check out in more detail. The links you can get whenever these slides are posted. And that wraps up our talk today. We'd like to thank you for coming, and come talk to us outside at the Google booth, talk about the challenges that your application has and about opportunities at Google. Thank you.